For as long as humans have looked up at the night sky, we have asked the same fundamental questions. Why do stars gather together instead of spreading out into empty space? Why do galaxies rotate in organized patterns instead of flying apart? And most importantly, what unseen forces shaped the universe into the structure we observe today? For centuries, astronomers could only study what they could see: stars, planets, glowing gas, and distant galaxies made of light. But over time, something didn't add up. Galaxies were spinning too fast. Clusters of galaxies were holding together more strongly than visible matter alone could explain. There had to be something else present, something invisible, exerting gravity without emitting light. That invisible substance is known as dark matter. Dark matter does not shine like stars. It does not glow, reflect light, or absorb radiation the way ordinary matter does. It cannot be seen directly with any telescope. Yet it makes up about 85% of all matter in the universe. That means everything we can see, every star, planet, and galaxy, accounts for only a small fraction of what actually exists. So, how do scientists know dark matter is there? They detect it through gravity. Gravity affects everything with mass, whether it emits light or not. When light from distant galaxies travels across the universe, it passes through regions filled with mass. If that mass is large enough, it bends the path of the light, much like a glass lens bends light in a camera. This effect is called gravitational lensing. By carefully measuring how the shapes of distant galaxies appear slightly stretched or distorted, astronomers can calculate how much mass is present between us and those galaxies. When they do this, they find far more mass than visible matter alone can account for. That missing mass is dark matter. Now, for the first time, scientists have mapped this invisible structure in extraordinary detail. Using the James Webb Space Telescope, along with data from other observatories, researchers from Durham University, NASA's Jet Propulsion Laboratory, and the École Polytechnique Fédérale de Lausanne created the most detailed map ever made of dark matter's gravitational influence. James Webb is uniquely suited for this task. Its infrared vision allows it to see extremely distant galaxies whose light has traveled for billions of years to reach us. Webb can observe these galaxies with incredible sharpness, detecting subtle distortions in their shapes caused by dark matter along the line of sight. By analyzing light from nearly 800,000 galaxies, scientists reconstructed a three-dimensional picture of how dark matter is distributed across vast regions of space. What this map revealed was, honestly, astonishing. Dark matter is not spread evenly throughout the universe. Instead, it forms a massive cosmic web made of long filaments and dense nodes. These filaments stretch across millions of light-years, connecting galaxy clusters like, well, invisible highways. At the intersections of these filaments, dark matter becomes especially dense. These dense regions formed very early in the universe, shortly after the Big Bang. Because dark matter interacts primarily through gravity and not through light or radiation, it began clumping together before ordinary matter could. Once dark matter gathered into these structures, it acted like a gravitational blueprint. Ordinary matter, made of gas and dust, was pulled toward these dark matter concentrations. As gas accumulated, it cooled and collapsed, eventually igniting nuclear fusion and forming the first stars. Over time, stars grouped together into galaxies, and galaxies gathered into clusters, all guided by the invisible framework of dark matter beneath them. This means galaxies did not form randomly, they formed where dark matter told them to form. In earlier observations, scientists could only see blurred hints of this cosmic web. The Hubble Space Telescope provided the first evidence that dark matter shapes large-scale structure. Ground-based telescopes added more data, but their resolution was limited. James Webb changed that. Its observations are sharper, deeper, and cover a much larger area of the universe. The new map reveals smaller clumps of dark matter that were previously invisible, refining our understanding of how galaxies assemble and evolve over cosmic time. This map does more than confirm existing theories. It allows scientists to test them. By comparing the observed distribution of dark matter with predictions from computer simulations, astronomers can evaluate whether our current understanding of gravity and particle physics is correct. Any mismatch could point to new physics beyond what we currently know. Most importantly, this discovery shows that the universe is shaped by an invisible partner to everything we see. Wherever galaxies shine, dark matter is already there, guiding their motion, controlling their growth, and holding them together across billions of years. As James Webb continues its mission, and future telescopes push even deeper into space, we are moving closer to answering one of humanity's oldest questions, not just how galaxies formed, but why the universe looks the way it does. A universe built not only from light and matter, but from invisible gravity, silent structure, and a hidden framework that holds everything together.